Welcome back, people. As promised, here's part two of our video answer key for the 3B review. So we left off here at 22. This is asking for the discriminant, and based on the discriminant, which is listed right here, b squared minus 4ac, determine how many and what types of solutions we're going to have. So if I did b squared minus 4ac, that'd be 20 squared minus 4 times negative 4 times negative 25. Numbers here are going to be getting kind of big, so I'm just going to use a calculator. So 20 squared minus 4 times negative 4 times negative 25. I get 0. So if it is 0, there is exactly one real solution. One real solution. All right. Now we're going to be solving systems algebraically. Here we've got two separate parabolas. If I kind of visualize what these would look like, I've got a downward opening parabola and an upward opening parabola. So without knowing specifics about vertex or y-intercept, whatever, I can kind of predict that chances are they're going to intersect at two separate points. Over here on 24, I'm going to have a downward opening parabola, and then I'll have a line with a slope of 1, y-intercept of 4. So that one might intersect at two separate points. Maybe it's a scenario where the line is above the parabola. Maybe it's tangent to it, so it only has one. Who knows? So that will be determined here in a second. So if we're solving this algebraically, let's just use some straight old substitution. So I'm going to put x squared plus 3x plus 2 in place for y in this first equation here. Since these are both equal to y, I can essentially just set them equal to each other. One thing that I do want to advise against is some of you might be looking at this and thinking along the lines of elimination and saying, oh man, I could just cancel everything out. And while yes, sometimes that might work, typically you're going to want to avoid doing that because the y's don't always cancel. And if you cancel out the x squareds without canceling the x's, then you're still going to have two variables left with only one equation now. So we just want to be a little careful with that. All right, so first thing I'm going to do is stack everything over to this side. So I'm going to add x squared, add 3x, and add 2. So I get 2x squared plus 6x plus 4 equals 0. Now I'm going to factor this and solve. When factoring, always look for a GCF first. Once I have that, I can go ahead and continue to factor. So numbers that multiply to 2 add up to 3 would be positive 2 and positive 1. My x values then are negative 2 and negative 1. All right, but now I need the coordinates. So I need to see what is the y value if x is negative 2 and what is the y value if x is negative 1. So I'll plug in negative. Let's do negative 1. Negative 1 is probably easier. Negative 1 squared plus 3 times negative 1 plus 2. So that'd be a positive 1 minus 3 plus 2. So 1 minus 3 is negative 2 plus 2, that's 0. So I'm going to have negative 1 comma 0. And then if I plugged in negative 2 squared plus 3 times negative 2 plus 2. Again, I have to plug in both points. I chose negative 1 first because it was easier. Negative 2 squared is 4 minus 6 plus 2. 4 minus 6 plus 2. Hey, that's also going to be 0. Cool. So negative 2 comma 0. Hey, got a little gross there. All right, number 24, very similar. The only difference here is the fact that we don't have two separate quadratic terms. So I'm going to set them equal to each other again. X plus 4 equals negative x squared plus 2x plus 10. Move everything over to one side. Here the x squared is negative. I don't like that, so I'm going to scooch that over. So positive x squared on this side. If I subtract 2x, it'd be minus 1x. Subtract the 10, that's negative 6. Set equal to 0. Then I factor it. There's no GCF to worry about. I'll get negative 3 and a positive 2. Those multiply to be negative 6, add up to a negative 1. Therefore, x equals 3, x equals negative 2. So then I get my points. I'm going to plug them into this equation because that seems a lot easier than this guy. See, 3 plus 4 would be 7, so 3 comma 7. Negative 2 plus 4 is 2, so negative 2 comma 2. Boom, done. All right, next problems. We are given the zeros. We want to write an equation in standard form. So we need to take an in-between step here. We're going to take the zeros to then write the factors. And then once we have the factors, we'll go to standard form. So use the zeros to get the factors and then go into standard form. All right, so if I have these two zeros here, a 0 of 5 would be produced from a factor of x minus 5. A 0 of a negative 2/3 would be produced from, anytime you have fractions, take your denominator and put that as the coefficient on the x, and then take the opposite of that numerator. So 3x plus 2 would be the factor from these two values. All right, so then we distribute. We'll get 3x squared to start off, and I know it's going to end with a minus 10. And then let's get that middle term. So I'd have a 2x and a negative 15x, 2 and a negative 15, negative 13x in the middle. Number 26. I know it has to have an x minus 7, but that's a linear term. That's not a quadratic. Quadratic says I need to have two separate x's. And I can't just throw a plain old x here because then that indicates x-intercept of 0. So I can just put a squared there. If I have one and only one 0, I'll just put a squared outside. So x squared minus 14x plus 49 is what I'd get if I did an x minus 7 times another x minus 7. On 27, we'll have x minus 2, x minus 6. Again, these are the factors. Then we distribute it out. I know it'll start off with an x squared. It'll end with a plus 12. In the middle, I'd have a negative 6x minus 2x, so negative 8x. All right, final page. Hey. 28, what are the factors? So again, factors indicate what are the parenthesis chunks. Well, I know I have an x-intercept here and here at negative 3 and at positive 2. So my factors would be x plus 3 and x minus 2. Part B is saying, is the discriminant positive, negative, or 0? Well, I know that there are two x-intercepts. Therefore, the discriminant has to be positive. Positive discriminants indicate two roots, two x-intercepts. Is the a value positive or negative? The a value dictates, does it open upward or downward? Well, clearly this thing opens upward, so this would be positive. All right, 29. Ooh, 29 is a calculator problem. Excellent. So let's go ahead and get our calculators ready. First thing we want to do is pop in my equation. So y equals negative 0.002 x squared plus 0.77x. And I probably won't be able to see the whole thing. That's okay. All right, so I know it should be making some sort of a parabola, right? A parabolic curve. Chances are I need to adjust my window. So I'm going to change this to 100 here and then 100 for the y max. We might need to go back and change that from there. All right, so it looks like my y max is okay, but my x max needs to go much further. I'm going to go 350, see if that does it. Almost. Let's go 500. There we go. All right. So there's really only a handful of things we can ask for, right? Where does it start off? How high does it go? How long does it take to get there? When does it hit the ground? And then I could even figure out when does it reach a certain height, and I believe that's one of the questions I will get to. So first, how far does a ball travel before hitting the ground? So I'm looking for this point right here. And my calculations option, that's going to be option 2. I need to establish a left bound and a right bound. So right there is fine for a left bound. I'll move it past the axis, so my y values are gone negative now. So somewhere in between there is 385, and that's when our y value is 0. So 385 feet is how far it travels until it hits the ground. How high does it go? So I'm looking for a maximum. So I go to my calculations. That's going to be option 4. So left bound, right bound here. Left bound, come on. Right about there's good. Right bound. Cool. And I'm getting the point 192.5, comma 74.113. So the height is represented by the y value, so 74.113 feet. When will the ball first reach a height of 50 feet? Now there's a few options for this. Option 1 is I could set my equation up above. I could set that equal to 50, move the 50 over to the other side, solve that by quadratic formula or by graphing, whichever you choose. Or I'm going to use my calculator to my advantage. I'm going to plug in a y value, straight line of 50. So that kind of tells me that threshold height. So really, I'm just figuring out when does this point happen. So I'm going to calculate when those two values intersect. That's going to be option 5. First curve, yes, is the parabola. Second curve, yes, is that straight line. Guess, I don't care. Oops, I should have hit the guess. Dang it. Let's try that again. So first curve over here, second curve. Let me get it away from that other intersection point. Anytime you have two values, two intersections, that guess value is when you kind of tell the calculator which one you're more interested in. There it is. Okay. So 82 point, let's call that 7 feet, because we're talking about horizontal distance versus vertical height. All right, reasonable domain and range. Well, the domain would be from 0 to 385, because that's when it hits the ground again. And then our range would be from 0, the starting height, up to the maximum height, which was 74.113. All right, home stretch, people, last one. First thing I'm going to suggest you do is kind of draw some sort of distinguishing line between imaginary and real numbers. Real numbers include rationals and irrationals. Those are subsets of real numbers. Imaginary numbers are their own separate beast. So if I look at the imaginary numbers first, then we can kind of rule out anything else. So anything with an I is going to be imaginary. Let's see, that would really be IRAD 3 for this, so that's imaginary. And then everything else will not use this column. So everything else will be a real number. And then within the real numbers, we just have to distinguish rational versus irrational. It's got to be one or the other. Anytime you have an irrational number, those typically show up as radicals that can't be simplified, or special numbers like pi or e, or things along those lines. All right, so -3 is rational because it can be written as a fraction. Rad 2 is irrational because it can't be simplified any further. 5i, we've already dealt with that one. 0.78, that's the same as saying 78 over 100. Well, there's a fraction, that's rational. 5, that would be rational as well. I could write that as 5 over 1. So there is our table. All right, that's it. That's all, folks. As always, if you have any questions, do not hesitate to reach out and ask for help.